Okay, let's give you guys some more practice. So use logarithmic differentiation to work out the derivative of this. And by the way, you could use a product rule. You could visualize it as one thing over another thing. So you could visualize it as like this: 1 over x 2x minus 1, and then to the power of a half. Okay, and then within here you could visualize it as x as x bracket 2x minus 1, and then all this here to the power of minus 1, and then you've got that square root, so to the power of a half here. So that equals x 2x minus 1, all to the power of negative a half, because you get this times this. Yes, you could use the product rule, the chain rule and the product rule to find the derivative of this, but learn to use logarithmic differentiation, because soon it will get more complicated. You could have something really complicated up here, so learn to use logarithmic differentiation. Okay, so anyway, find the derivative of this, but use logs. Okay, so this visualize as this to the power of a half, and then take the natural log of both sides. So this one here will move up. Well, just try it. Okay, so press pause and have a go. Okay, so to do this here, visualize this thing here as y equals this thing to the power of half. Okay, and then take the natural log of both sides. So this 2 will go out here. Sorry, this half will go out here. That's this half here. Okay, and then you've got the natural log of the whole thing up here. Okay, so from here, take the natural log of both sides. That would then take you to here. Okay, so now just looking at this bit here, that would then become this. Okay, because whenever you have the natural log of a over b, that's the same as the natural log of a minus the natural log of b. So that's this thing here. Okay, and then this bit here is equal to 0, because when you look at this here, imagine there's an e here, so e to the power of what gives us 1, and the only answer here is 0 here. So, well, anyway, this bit here will be 0. Okay, and then later on this half times 0, and then half times this thing here. So that would then give you this. Okay, so yeah, and then now looking at this bit here, you've really got, what you've got here is really one bubble multiplying another bubble here. So whenever you have log of a times b, that's the same as the log of a plus the natural log of b. So you can split this up. So that's this bit here, and then this bit here. Okay, so now you're ready to differentiate. So use well, and then differentiate both sides. This one here will give you 1 over y times dy by dx, because y is a function of x, and then this bit here will be 1 over x, and this bit here will be 1 over, well, this bit here will be 1 over 2x minus 1, but and then you've got to find times the derivative of the bubble itself, and this 2 here is this 2 here. Okay, and then now what? Oh yeah, this 2 here gets multiplied to the top, and then try and merge these two fractions together, and then yeah, so try and merge. So at the moment you've got this fraction plus this fraction here, and then merge the two together. So it's blah 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 here. Okay, blah 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 blah, and then you would get to this stage here, and then don't forget, yeah. So hang on, let me think. Oh yeah, sorry. When you get to this stage here, imagine it as a minus 1 here. Okay, imagine it as a minus 1. So it's minus 1 times this thing here. So this will become a minus. This will become a plus, and then switch these two around. That will give you this and this here. Okay, and then the 2 will get multiplied to the bottom. That will then give you this. Okay, so so at the moment it's at the moment it's 1 over y times dy by dx equals this thing here. So now times both sides by y. That will then give you y times this thing here. Okay, and then remember that originally y was this. The original question was y was this. Now you can put this whole thing into the y here. So that will then give you this. Okay, so dy by dx equals this block times this block here. Okay, you could, if you want to, simplify this. But jump to a graph plotter, plot your original y equals blah blah blah. The red line was our original y equals blah blah blah, and the blue line is the derivative. So now have a quick glance. Looking at the red line, you can see that the gradient, the derivative, must be negative. It's going downhill. It's negative, and then it should get shallower and shallower and shallower. So now looking at the blue line, it is indeed in the negative realm, and it's getting the derivative gets smaller and smaller and smaller. So that makes sense. Now looking at the red line, you can see that the derivative, the gradient, should be positive, 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 and it's quite shallow, and then all of a sudden it gets steeper, and it gets a lot steeper. Now looking at the blue line, it is positive, positive, positive. It's in the positive realm, and then it gets really steep, really steep. So the two graphs tallies up with each other. It makes sense. So so this here seems to be correct. This is our derivative here. Okay.